Okay, in this video guys, I'm going to simplify expressions, solve linear equations, multiply brackets, and evaluate expressions. Okay, so the first thing I'm going to do is I will simplify expressions. Simplify means, I suppose, as it states, make simple, right? So we'll turn or try to turn big, long expressions into smaller expressions by adding things together. So for instance, over here we have 3 apples and 4 oranges and 2 apples and 3 oranges and a banana. Well, if I was to simplify that, I would take my apples and I would add them together. So we have 3 apples and 2 apples, so that's 5 apples. Then I take my oranges, 4 oranges and 3 oranges, which is 7 oranges, and we've 1 banana. One banana. Okay, and that's as simple as we can make it, because we can't add apples and oranges and bananas together. Okay, they're different things. Likewise over here. So I have 6x x minus xy plus 5x minus 7xy. So what we do here is we look for things that are the same. So I have a 6x. Now by any other x's that I can add to that, I can't add this to it because this is a minus xy. Okay, so that's not an x, that's an xy. But I do have another 5x here, so I can add these x's together. And if I add 6x and 5x, I will get, I'll get 11x. Now I look and I see I have xy's. I look and see if I have any more xy's. There's more xy's. Now, how many xy's are here? Well, 1. Even though the 1 isn't there, it's implied. So I have minus 1xy and minus 7xy. Again, our rules now of addition. Okay, so when the signs are the same, they are the same. There's a minus, there's a minus. So when the signs are the same, we add the numbers. 1 and 7 is 8. And use the common sign. Well, the common sign is minus because they're both minus. And there's our answer. Okay, so there's an example of simplifying expressions. Solving linear equations. Well, we will start by looking over here. We have a, I suppose, a scales, and the scales is balanced because up here we have an equal sign. Okay, an equal sign in the middle. And on one side of the scales we have 3x plus 4, and on the other side of the scales we have x plus 12. Now, like the old days with these old scales in ancient Egypt, they would have actually had to use algebra to find out the weight of loaves of bread and things like that. And they didn't just have a scales like we have now where they can put it on the scales and it just tells them how heavy it is. They would have had weights on one side and bread on the other, and they would have had to use a bit of algebra. So we'll use the scales in order to solve how big x is, or what x is worth. So what I'll do is I've decided that I'm going to bring my x's to this side. So I'm going to have x's on this side, and I'm going to have numbers on this side. So if I want to have x's all over on the left side, I want them gone from the right side. So I see an x on the right side, so I'm going to take away an x on the right side. Now if I take away an x on the right side, I have to do the same to the left side, because I need to keep this balanced. Okay, I have to keep this balanced all the time. So if I do something to one side, I do it to the other. So I take away an x. Well, if I take away an x on the right side, it will disappear, and I'll be just left with 12. And if I take away an x on the left side, well, the 3x will turn to 2x. Okay, now I have a 4 on the left side. I want to get rid of that because I want the numbers on the right side. So I will take away 4. And if I take away 4 on the right side, I must take away 4 on the left side. So this 4 will disappear. I'll just be left with 2x. And this 12, well, take 4 away from that, and I'll have 8. 2x equals 8. If I divide this side by 2, I'll just be left with x. If I divide this side by 2, I'll be left with, well, 8 divided by 2 is 4. So x is 4. Okay? I do the same on this side. This is the same equation. Okay? So, and off we go. We put in our stabilizers, and I want my x's on the left side, so I'll take away x here. I must do the same to the other side. So 3x plus 2, or sorry, 3x plus 4, take away x, so 3x, take away an x, we'll be left with 2x plus 4 equals, and again I take away an x here, so I'll be left with 12. I now want to take away a 4 on this side because I want this gone, so I take away a 4 on the other. I will be left with 2x equals 8. 2x equals 8, I'm going to divide by 2 on both sides. If I divide by 2 on both sides, I'll have x equals 8. Okay. Just one thing to note. This was a plus 4 here. So to get rid of it, I had to minus 4. If this was a minus 4, well then I'd have to plus 4 here to get rid of it. Okay, because minus 4 plus 4 is 0. So that's how I get rid of it. Okay. Multiplying out brackets then. Right. So when I'm multiplying out brackets, 2 brackets stuck together, nothing in between, okay, which implies they're being multiplied by each other. So we do first number by first, first by second. So 2x by 3x, well, 2 by 3 is 6, x by x is x squared. And then 2x by minus 4, well, 2x by 4 is 8x. And now think, rules of multiplication. We have a plus 2x, we have a minus 4. Unlike signs give minus answer. This by this, and this by this. So minus 3 by 3x. Well, we'll just go the numbers together first. So 3 by 3, 9. There's only one x here. Okay, so it's just one x. There's no squares or anything like that. And the sign, it's a plus 3x, it's a minus 3. Unlike signs give minus. And the last one, minus 3 by minus 4. Well, 3 by 4 is 12. And like signs give plus answer. Okay, there's the rules of multiplication. Now we're going to simplify. We're going to look and see if there's anything, I suppose, the same or similar. We have a 6x squared. Have we any other x squareds? No. So that will just stay as 6x squared. We have an minus 8x and a minus 9x. So they're the same. So we can add those together. Minus 8x and minus 9x. Well, when the sign, this is rules of addition now. When the signs are the same, we add the numbers, 17x, and use the common sign. They're both minuses. And we still have a 12 left over. So there's the answer. Okay, on to example 2. Same again. First number by first, first by second, first by third. So 2x by x squared. Well, have a think now. This is an invisible 1 here. So 2 by 1, 2. X by x squared. Well, there's 2x squareds here. There's there's 2 x's here multiplied together. There's an x here, so there's actually 3 of them being multiplied. 2x by minus 3x. 2 by 3, 6. X by x, x squared. The signs now. We have a plus, we have a minus. When we're multiplying, unlike signs gives us minus answer. 2x then by 5. 2 by 5 is 10. We only have one x because there's an x here. There's none over on the 5. And the sign, we have a plus 2x, we have a plus 5. So like signs gives us plus answers. And then with the minus 4 by that, and by that. Right, minus 4 by x squared. Minus 4x squared. Minus 4 by minus 3x. Plus 12x. Minus 4 by plus 20. Minus 20. Remember, unlike signs, give minus answer. Just a bit of simplifying here then. So, any other x cubes? No. So that's on its own. Any other x squareds? Yes, we have a 6x squared, a minus 6x squared and a minus 4x squared. So we can add those together. Now, rules of addition. When the signs are the same, we add the numbers. 6 and 4, 10x squared. And use the sign, and use the common sign. Common sign is minus. Have we any x's? We have here and here. 10x and 12x, 22x, and it's plus because the signs are the same. We add the numbers and use the common sign. And lastly, we have a minus 20 here on its own. And there we go, that's that done. Okay? Remember, we can only add, I suppose, numbers or variables that have the same indices. So we can't add 2x cubed and 6x squared. We can't add those. Also, when I'm adding 10x and 12x, it's 22x. The indices doesn't change, so it's not 22x squared. Okay, the indices will only change when we're multiplying. For example, up here, 2x and 1x squared. I'm multiplying x squared by x, so there's 3 x's being multiplied together. So that would be x cubed. Okay. Lastly, we're going to solve this one here. Okay, again, number outside a bracket, so it'll be multiplying it. 5 by 2x, 10x. 5 by 6, 30 equals 60. For your stabilizers, I'll take 30 from this side, I'll take 30 from that side. I'll be left with 10x equals 60, and divide by 10x equals 10x equals 30. Okay, 10x equals 30, divide by 10, divide by 10, x equals 3. Okay, nearly there. Evaluating expressions. Okay, let's have a look at this one. 3 oranges and 5 apples equals what? If an apple is €2 and an orange is 3. Okay, well, we have 3 oranges, and in brackets I'm going to say an orange is €3, and 5 apples, and we say an apple is €2. Okay, so we have 3 oranges here, so 3 3s are 9, plus we have 5 apples and they're €2, so 5 2s are 10, which equals 19. Okay, so if we look over here, I'm going to evaluate this. We have 3x plus 4y squared, and I've been told that x is 1 and y is 2. So anywhere I see an x, I'll put a 1 in brackets. And anywhere I see a y, I'll put a 2 in brackets. Okay, indices first, remember, BIMDAS. So brackets, indices. So there's nothing in the brackets to do here. Okay, so the next step is our indices, which is the squared. So 1 plus 4, and 2 squared is 4. 3 1s are 3, 4 4s are 16, and 3 plus 16 is 19. Okay, and that's just a coincidence. Okay, hope that helped, lads. Thank you. Bye.